All right, so now that we've worked with arithmetic sequences and series, we're ready to tackle geometric. To define a geometric sequence or series, it basically is a sequence or series that has a common ratio. So they're the ones that instead of adding or subtracting by a number to get from one term to the next, you're actually going to be multiplying by a number to get from one term to the next. And I know some of you might think of it as dividing as well, but really we have to think of it instead as multiplying by a fraction. So in geometric sequences, you really are just multiplying by the same number every time. So we call that number that you're multiplying by every time a common ratio. And to get a common ratio, you're taking one term in a sequence or series and dividing it by the term right before it. That's what this a sub n plus 1 divided by a sub n means. So if I gave you this sequence, 2, 6, 18, 54, hopefully you can look at that really easily and say that the common ratio, you're multiplying by 3 every time. But if we were to use this formula, technically what you're doing is taking 6 and dividing it by 2, or you're taking 18 and divided by 6, or 54 divided by 18, and each time you're getting the same number, 3. Okay, so what is the formula that we're going to use to figure out the nth term of an arithmetic sequence or series? So that general rule, right? And so that formula is given right here. It's a sub n is equal to a sub 1, the first term, times the common ratio raised to the power of n minus 1. So that's really important that that is just n minus 1. Okay, and what you're going to find, I think, is for the most part, these are pretty easy. So here's the first example. We're going to find the 8th term of the geometric sequence. Okay, so just to help us out, you're going to put the first term, and then the common ratio, and then your n is 8. So you plug that in, 8 minus 1, and you actually just work that all out. And when you do that, you get 128. Okay, so a lot of this stuff, because these are numbers raised to big exponents, you'll probably be using your scientific calculator to do that. All right, here, let's try another one. It says to write a rule for the nth term of the geometric sequence. Then find a sub 10. All right. So using that formula, we're going to need to know what the first term is, which we can see is 5. We need to know what the common ratio is, which you're going to need to figure out. And we're going to need n, right, to figure out the 10th term. So let's start off by finding r. So what is the common ratio? I hope you guys all said 3, not 1/3. Okay, so you are multiplying by 3 every single time. All right, next part. We need to find our rule. So finding the rule is actually super quick and easy because we have everything we need and there's no simplification. So we just plug in everything that we have. We have the first term, which is 5. We have our common ratio, which is 3. And you just raise that to the exponent n minus 1. No simplifying, you're done. Pretty cool. All right, and then the last part says to find a sub 10, right? So now what you're going to do is plug 10 in for n right here and calculate. I'll give you a second to do that. Okay, so hopefully you plugged in 10, you worked it out, and you end up getting this really large number, 98,415. All right, I think we're ready to move on to the next example. So this one's a little bit more complicated, just like with the arithmetic sequences. I'm now just giving you one specific term, which it looks like I'm giving you the 4th term is 12, and I'm going to give you the common ratio is 2. You need to write a rule for the nth term, and then graph the first 5 terms of the sequence. So I put our little formula up here just to remind ourselves. But the first step is to figure out a sub 1, because we don't know that yet. So let's plug in what we have. We're looking for a sub 1. This is going to stay a variable. We know a sub n is 12. Actually, a sub 4 is 12. So this right here is going to be the term 12. We know r is 2, so I can plug 2 right here. And then I know n is 4. So this 4 is going to get plugged in right there. And when I do that, I can now solve for a sub 1, because that's the only variable left in the equation. So this is what that would look like. Okay, so let's clean this up a bit. That's going to be 2 cubed, and I can figure out that that's 8, and then I can divide both sides by 8, and I get the first term is 1.5. All right, step 2 is to write the rule for the nth term. So now that I know the first term, and I know the common ratio is 2, writing the rule is super easy. So there you go. Okay, so to find the 5 terms of the sequence that we need to graph, well, we already know the first term is 1.5. You have 2 choices. You can either plug in 2 for n, 3 for n, 4 for n, 5 for n. You can do all of that with this formula. Or, since we know that the common ratio is 2, just multiply everything by 2. So 1.5 times 2 is 3. 3 times 2 is 6. 6 times 2 is 12. And then 12 times 2 is 24. So you could do all the work that I have shown here, or you can do the quick way and just multiply by the common ratio to get each term. All right, so the last step here is for us to graph the first 5 terms of the sequence. So here's our graph. Let's go ahead and do that. So at 1, we're at 1.5. At 2, we're up here at 3. At 3, we're all the way up at 6. At 4, we're all the way up here at 12, way off the graph. And then 5, we're at 24, which is like all the way up here. So, I mean, it's actually technically probably off of the screen, way up there, but that's as far as we can go. All right, so I have one question for you. Okay, so hopefully nobody has connected the dots, just like when we did the arithmetic graph, arithmetic sequence graphs. Don't connect the dots. This is discrete, not continuous. So we should just see these individual points graphed. All right, that's it for now. Later, guys.